Hey guys, welcome back to Sports Betting Truth, and today on the Sports Betting Truth Baseball Modeling 101 series, if you want to call it that, we're going to talk about neutralization. Now, neutralization is very important when you're building a model for any sport, but especially baseball because of all the external factors in play, and you want to make sure you can compare every player and batter and pitcher in every ballpark, weather situation, whatever it is, apples to apples. Neutralization allows you to put every single player's stats on a level playing field so you can truly compare them. Because, for example, a player who hits 40 home runs at Coors Field is not as impressive as a player who hits 40 home runs at Tiger Stadium or Comerica Park, whatever you want to call it these days, or at AT&T Park in San Francisco. You want to make sure you're factoring these things in when you're calculating your stats for every player. If you're not, then you're going to get some stats that are not correct when you're trying to predict outcomes, especially when it comes to a betting model, because I can assure you the bookmakers are factoring these things in, so when you make sure you want to do it. Now, there's a lot of different ways you can neutralize, so let's get into the details. All right, so I follow a pretty specific pattern when it comes to neutralizing stats with my baseball models, and I think these things are all pretty necessary if you want to have a good baseball model. I don't think they're all required, but they're things to keep in mind if you're trying to get the best baseball model you can make. So I start off by calculating all player stats versus the league average. This is mandatory because you need to know how a player compares to the league average. That's how you can't neutralize without league averages. That's just part of it. Every sport I model for, not just baseball, I calculate everything against the league average. Not just for current seasons, but it helps with past seasons too, especially if, like, for example, in basketball, say the three-point line gets moved back. Well, if you have versus the league average three-point stats for all the players and teams, then it's not going to matter because you'll know how a team did against the league average instead of how a team did in that context of that season. So, for example, in baseball this year, if they de-juiced the ball, so to speak, so home run rates are probably going to be down this year. They already are. I've checked. And if I didn't calculate all my past stats against the league average, then everything would be only in the context of the circumstances of the previous season. So it really helps doing versus league average calculations, not just for neutralization, but just so you can trend year over year and not have to worry about the rule changes or anything like that. So once I have everything against the league average, the next thing I do is I weather neutralize. So I'm going to show you everything in a little bit more detail, but this right here is just going over the flow chart to start off with. So I pretty much take every player's stats, every player's at-bats, what the weather was for all their at-bats, and I neutralize for weather, meaning if it was a really hot day, because I found that temperature really correlates to higher scoring and more home runs and stuff, then a player's stats are going to be adjusted downward for that day because of the temperature. Same with the wind and everything like that. What you're trying to do with weather neutralization is you're trying to neutralize a player's stats to say, okay, if every single at-bat the player had was in a dome at 72 degrees with no wind, what would the player's stats have been? You want to take the weather effects out of it. Because, for example, a player that plays, or at least in the old Rangers ballpark, one of the most hitter-friendly ballparks because it had the highest mean temperature of any ballpark in the country, it's going to have a different stat line than a player who played in San Francisco, where most of their home games are played, in the dead Bay Area air and the temperatures in the 50s and 60s. So you want to make sure you're comparing players apples to apples because it's more impressive to hit 40 home runs in San Francisco than it is to hit 40 home runs in Texas just by weather alone. So you want to take that in consideration. Also for like Cubs games, when the wind's blowing out and the totals are like really high because of that wind at Wrigley Field, you want to neutralize for that too, because it's one thing you want your model to treat a home run hit with like a wind to your back at 20 miles an hour differently than a home run that you hit into the wind at 20 miles an hour. So that's what you're trying to do with weather neutralization. You're trying to adjust the weather and take all the weather effects out of every player's stats. And then I move on to park factor neutralization with weather neutral park factors. So park factors are pretty much how a park's dimensions play in terms of the overall stats in that ballpark. And I'll explain how to calculate them in a second, but pretty much, for example, Colorado and San Francisco are notorious for being able to hit triples there because of the dimensions, right? So and Fenway Park has a lot more doubles than the average park because of the Green Monster. Detroit doesn't have a lot of home runs because of the far fences. For all these things, you want to take into consideration. That's what you're doing with park factors, but you got to be careful here when you're calculating park factors, because how much of the park factor is because of the park's dimensions and how much of it is it because of the weather? For example, San Francisco, how much is their low home run rates and everything like that because of the weather, and how much of that is because of the park? Well, what you want to do, that's why I do weather neutralization first, because I calculate every player's weather neutralized stats, and then I can calculate park factors from the weather neutralized stats, and therefore the park factors are going to have the weather taken out of it. That's the idea. That's why you do weather first, but you're trying to adjust with park factors. The thing is, most people who do park factors don't take the weather out of it. So, for example, San Francisco, probably the best example of this, is going to be a team where most of their park factor is influenced by the weather and not the dimensions. And then after I've weather neutralized and park neutralized, then we do home advantage neutralization. Now, over a 162 game season, every team is going to play 81 home games, 81 away games. So this isn't as important as, for example, college football or college basketball, where a lot of schools play a lopsided schedule where most of their games are at home. But you got to remember, for baseball models, if you're doing a team-based model, it's one thing. But for a player-based model like mine, I do home advantage because every player is different. Maybe a player joined the team mid-season and played more home games than road games. Maybe he got hurt. Every team is different. Every player is different. They're not going to play every game. Unless you play all 162 games, you want a home advantage neutralized. You want to take the home advantage into consideration when calculating their stats, and calculate their stats as if they played every game at a neutral site. And then finally, opponent adjustments. I've talked about this in many videos before, but I do it in baseball. I actually really waffled on this before the season started, whether or not it was worth it. And I think it is, because like I said, every player is different. Every player faces different pitchers, different teams. For example, say a team in the NL Central, every team in the NL Central is going to play the Dodgers 6 or 7 times this year, right? Say the Reds had to play the Dodgers and face Trevor Bauer twice. And say the Cubs got to face the Dodgers and didn't have to face Trevor Bauer in either of their series. The Reds, while both teams played the Dodgers 6 times, the Reds had to face Trevor Bauer twice. The Cubs didn't have to face Trevor Bauer at all. That's a good example of why you want to opponent adjust, and adjust every player's stats on the strength of the opponents they have played. Specifically for batters, you're going to adjust their stats on the strength of the pitchers they faced, and then for pitchers, you want to adjust their stats based on the strength of the batters they faced. So that's the idea. For example, say a team played a good team in April, and then the other team didn't have to play them until September, where a bunch of guys got hurt and had a bunch of minor league call-ups, and their roster was basically a AAA roster. That's why you want to opponent adjust. You want to make sure everybody is on a level playing field. And also, you got to remember, teams don't play balanced schedules in Major League Baseball. Every team plays an unbalanced schedule. Most of the games are against teams in your own division. So if you have a team that plays in a weak division, loading up against all those easy teams, and then you have other teams in a hard division, you want to make sure you're adjusting for that as well. And that's why you opponent adjust. So that is the waterfall that I use when it comes to neutralizing stats. And now I'm going to go into more detail. So here's my stats folder, and I have over 1,000 files in here because everything is neutralized. So like I said, the first thing I do, I showed you this in my last video, but I calculate league averages among 13 different categories. For me, if you didn't watch my last video, I calculate the average stats for 11 different outcomes. And then for batters, for pitchers, pitchers that are batting, so basically this is National League pitcher batting stats overall, and then the total league average. So if you want more on that, watch my most recent video on percentages. And then from there, you can calculate every player's versus what I call the versus league average stats. So I'm going to open this file right here for 2021. This is right-handers facing this is right-handed batters facing right-handed pitchers versus the league average. So let me see if I can identify any players' numbers. I don't know any of these numbers by hearts, guys. So whoever 405.395 is, he hits about 0.005% less doubles than the league average. His outs he flies out 5% more than the league average, than a league average right-handed batter would against a right-handed pitcher. Anything else? He strikes out about 8% less than the average right-handed batter against a right-handed pitcher. That's what you're calculating here versus the league average, not their overall stats, which I do have. I do track those things, but remember, it's versus the league average. And then I weather neutralize. So I'm going to open this file right here. This is right-handed batters versus right-handed pitchers, weather neutralized stats. So remember, this guy flew out only 5% of the time versus the league average, but when he weather neutralized, it goes up to 5.5%. He struck out about 7.9% less than the league average, but weather neutralized, it moves up to 8.4%, as you can see. What I found with weather is that the most meaningful impacts on stats are going to be home runs, singles, and doubles, and flyouts. Those are where weather really affects things. Like everything else is pretty much noise, but it's those 4 stats where weather plays a factor. But you still want to do it for all the other stats anyway, just so everything totals 100% on the averages. So the way I do this, so I have a file called WX. Let me open 2021s for you. So what I do is I scrape weather data for every game, and then I merge it onto my savant frame, right? So on April 6th for the Dodgers and the Angels and Astros game, the temperature was 70 degrees, wind was going to left field at 8 miles an hour, right? So that's pretty average though. Like the average temperature is 72. Wind to left is going to help the offense a little bit. So that's how it would affect Kyle Tucker. And then what I do is I group every player's stats down and group their weather information and run a regression of how weather impacts a game, a linear regression plugging in the wind speed, wind direction, and temperature, and add that onto their stats, right? Their overall stats. I know it sounds complicated, but that's how. I wish I had a better way to illustrate how to do it. Let me do just a random guy, Jose Abreu. Right, here's all his at bats this year. Right, so what I'll do over here is I'll calculate how many times I'll do a group by in Python and calculate how many times, for example, he's hit a home run, how many times he's hit a single, and I'll get his averages, which I've already done. And then I have what I call a regression column. So I run a linear regression based on the weather and what the linear regression changes would be according to the weather, and group those down. And then I subtract his versus league average versus the weather regression group by combination, and there you go. That's how I do weather neutralization for Jose Abreu. For example, this 54-degree game, this 47-degree game, those are cold weather games, so his stats are going to be adjusted upwards for offensive stats. I can tell you that. Before I move on to park factors, what I found about weather is that temperature has the most impact. Temperature definitely has the most impact. So here's all my regressions right now. These are all my regression files that I use to regress on. So what I did is, maybe I can illustrate this on stream, so this is like 2008, right? So let me do a quick regression to show you how temperature affects home runs. I'll do it here in Excel just because it's easier. For the Y column, I will put home run percentage, and then for the X column, I'll just do temperature. This is going to be a very quick regression, right? Okay, as you can see, the higher the temperature goes, the more the home run line slopes up. The intercept is minus 0.1, and the coefficient is small but meaningful. And the p-value is very low, so it correlates. So the higher the temperature, the more likely the player is going to hit a home run. I also use wind speed and wind direction as well. I plug that in, and then I plug in the temperature, wind speed, wind direction into a regression and calculate, okay, if the temperature is whatever degrees, so observation 1. In observation 1, the temperature was 68. So when the temperature is 68 degrees, the average home run expectation should be decreased by about minus 0.16%. That's basically what this regression means. And so I do that for every at-bat, every player, what the weather was for their games, and that's how I can adjust for weather. But I found that temperature, more than anything else, affects home run rates. And then wind speed matters, but not like you think it was. I think wind direction matters more than wind speed. So if the wind's blowing in, from what I've found is that wind blowing in matters more than wind blowing out. Like wind blowing in has a much bigger effect on home run rates than wind blowing out. And you would think that like 30-mile-an-hour wind blowing out would mean more home runs, but actually it's the opposite. Yes, the wind blowing out is better for the batter in terms of home run rates than the wind blowing in, but actually the higher the wind speed when the wind's blowing out, the worse. Let me see if I can show you that here. So when the wind's blowing out, this was 2008, by the way, so this is a one-season sample size, so it might not confirm what I'm trying to convey, but here is a data frame of only wind blowing out, and let me regress it on wind speed. So the Y value is going to be home runs, and the X value is going to be wind speed. And if my past analysis is right, the line should slope downward. Not quite. It's pretty much flat, but overall, when I combine every season that I've regressed this on, it slopes slightly downward, implying that the higher the wind speed when the wind's blowing out, actually the lower the home run rates. And so to recap weather from my findings over my analysis, temperature matters most, then wind direction. And actually, while when the wind blowing out is better for home runs than when the wind is blowing in, the wind speed, actually the higher wind speed is actually worse. So that is what I have found in terms of weather. And then once I've weather neutralized every player's stats, so I do this in tiers. So I actually have every level of frame in here. So once I have adjusted every player's stats for weather, then I can move on to park neutralization. And here is this. So this is left-handed batters versus right-handed pitchers. That's what this frame I'm about to open represents. So batter 44482, when you take his park factor weather neutralized stats out, these are his stats, as you can see. And let me show you my park factor frames. So this is my weather neutral park factor frame. So I'm going to sort this, right? I'm going to sort it. So I'm going to sort it by triples. I guarantee you Colorado is going to be at the top. And they are. I didn't even, like I said, I just know these things. I've done this a lot. And so, but how much is that triple rate was because of the weather in Colorado, which they play a lot of games in 90-degree temperatures, guys. And how much is that is the dimensions? Well, I weather neutralize that, and it still has Colorado at the top. And here's San Francisco as well, another team. And I also do it by split. So I do park factors for lefties and then park factors for righties. So if I sorted it by home run, the Reds have the best home run rate weather neutralized. And when I do the opposite, Oakland and Texas have the lowest home run rates, and for left-handers. And I can see that. Oakland is like San Francisco. They play a lot of 60 and 50-degree games in dead air. But even when you factor that out, they still have the lowest home run rate in baseball when it comes to left-handed park factors. So that's what these numbers represent. In Oakland, when you take the weather out, there is 0.1 or there's 1.5% less home runs on average than the average park. In Texas, it's 1.4% less. In Cincinnati, the home run rate is about 2% more than the league average. You want to make sure you're taking those things out of a player's stats. And then I move on to home advantage neutralization. So I calculate what I call the home advantage frame. So this is your home advantage frame for this year. It's kind of hard to calculate. I kind of had to do like a weighted average, and because remember there's no fans last year, and that does matter. But here's what I have right now. Obviously, here's home teams and here's road teams. So for home teams, you can see at least for double rates, every single split is positive, and for away teams, every single split is negative. So there is a home advantage for doubles. Home runs are a lot less pronounced. It's pretty much even, Steve. Hardly any advantage at all. But you want to calculate these things anyway. Singles are also very, very low. Like the only thing I can really see advantages is just with this is walks, triples, and doubles. Everything else is pretty even Steven. So, but still, you want to calculate these things just to know. So you want to see, okay, maybe a player has played 10 home games and 5 road games. You want to adjust for that. You want to take that into account. So once I have the park factor weather neutralized frame, then I can go into park factor home advantage weather. See, you can see, if you can see my final names, they're all abbreviated, right? So this is the next step in the waterfall. Home advantage, park neutralized, weather neutralized versus league average frame, right? And you can see how a team's or a player's stats change through every step of the process. That's why I like to keep every frame separate, so I can audit and make sure the changes are good. That's why you want to do them all separately, just to make sure everything's on the up and up. And then finally, once I have done that, then we can start adjusting for opponents. And I do 2 rounds of adjustments. You want to keep going until you want to do as many adjustments until the stats stabilize. I found that I've only had to run it twice until they stabilize. So when you're adjusting for opponent, you want to see how, for example, if you're doing a batter adjustment, you want to see how all the pitchers he has faced, how their stats compare to the league average. So if the cumulative pitcher statistics that a batter has faced gives up 2% more home runs than the average pitcher, then you want to subtract 2% from the batter's season stats to neutralize that, cancel that out, because he's faced, a group of pitchers that give up more home runs than average. That's what you're doing with adjustments, and that's why I do it twice. So here's round 1, lefties versus right-handed pitchers, as you can see, and then I do round 2. And that round 2 is actually the final round. And that's the final file. That's the end of the road for neutralization. Let's go back to the beginning. We started with this frame right here. This is the averages for the season. So after 43 plate appearances, this is also imputed as well. So this is a synthesis of his preseason player projections and his current stats. So let's see who this player is, just so we can give him some context. Okay, it's David Peralta. So David Peralta on the season, this 43. So this stat line right here is probably about 30% current season stats and 70% preseason projections. He strikes out about 21% of the time. He homers only 2.3% of the time, doubles 2.3% of the time, singles about 6.9% of the time. You get the idea. as a left-handed batter against right-handed pitchers. However, then we want to know how that is versus the league average. So I'm going to open this file right here. Versus the league average, he actually doubles more than the average batter, but he homers less than the average batter and singles about 1.5% more than the average lefty against a right-handed pitcher, right? And then when we run it through all the neutralization, here's his final output. And let's see how his stats have changed. I'm going to bold this so you can see it easier. All right, so here's where we started. We started with a double percentage .006 higher than the league average and a home run percent minus .01 than the league average. And now, after we've adjusted everything, his home run percentage has stayed the same, and his double percentage has gone from .006 to .008. So not much has really changed. His walks went to -03, so there has been a little bit of change. His triple percentage went down by about .08. His ground ball percentage went up quite a bit. From .055 to .081. So that's how things have changed. These are his neutralized stats. This is what David Peralta's expected stat line would be against the league average pitcher in a dome with no wind, 72 degrees in a neutral dome as well. All that taken out, this is what his expected stat line would be against a right-handed pitcher as a left-handed batter. And that's what neutralization is. I know it's pretty complex, but I feel like it's the best way to do things when it comes to building a model that is unbiased and accurate. And I know what you guys are going to say. So you're probably going to be like, well, so at what point do you factor that in for a player? Like at what point do you factor in the weather and home advantage and park factors and all that? Well, I factor it in on the back end. I add all that back in when I'm doing the Monte Carlo run for my baseball model. So here is the... on my website, here's the Phillies versus Mets projected box score from today, April 15th. I factored all this in. Like I factored in the park factors for Citi Field where the Mets play. I factored in what the weather was. We'll be able to see what the weather was. So the weather was 54 degrees, 9 mile per hour wind out. So it's going to be more low scoring than average because of the low temperature, although the wind going out should help a little bit. I factored in each... let's see, Jacob deGrom, one of the better pitchers for the Mets. I factor that in, which is why the Phillies were only expected to score about 3.34 runs, with an average against .226 against him, and deGrom's expected average against .215. So I factored all that in. Trust me, I factored in the home advantage for the Mets and the road disadvantage for the Phillies. So I factor all that back in, I put it back into the mix while I'm running the simulation for the game. That's why you want to neutralize things. So when you're running the simulation, you can add those things back in then. And that way, the player's stats are not being influenced by those things until then. And that is how neutralization works and how you add them back into the mix afterwards. But I do have a video coming up about projection systems, and I'll probably go more into detail then in terms of like adding those things back into the mix. But that's how it works. Well, I know that was pretty high-level stuff, and it is, but it's all necessary. Like I said, the point of neutralization is to make sure everybody is on a level playing field so you can truly compare every player apples to apples. Like I said, you're trying to estimate what a player's expected stats would be in a completely neutralized league average situation with all external variances taken out of the equation. Once you can do that, you can really go to the next level when it comes to your modeling, not just in baseball. Like I said, I do this for college football. I do it for college basketball. I do it for all sports I model for. So it's very important. It's time consuming, but it's worth it, especially if you want to gain an edge. Well, anyway, that wraps it up for this video. The next topic we're going to cover is going to be on Monday, April 19th, and we're going to talk about player projection systems. Extremely important in baseball. So we're going to cover that. Get ready. Anyway, until next time, this is Sports Betting Truth signing off.